So this will be the end of section 2.4, and I won't do every one of these problems, but I'll do probably half of the rest of the section. For the next few problems, the denominators aren't the same. Both denominators are going to be able to be factored, and if you factor them correctly, each factoring will have a common factor. So for these problems on the second part of the video where both denominators can be factored, the first thing I'm going to do is I'm going to factor each denominator, and then I'm going to rewrite the problem with the common factor first. So as I go through to do number 30, I'm going to factor the first denominator of b squared plus 5b plus 4. And to factor it, I know my signs are plus and plus, and the numbers, they need to be double plus, they need to multiply to 4, and they need to add to 5, and that's just going to be 1 and 4. So I'm going to sight factor this first denominator because it's a trinomial and there's not a number in front of the squared term. And when I do this, the factors I'm going to get, one of the factors is going to be a b plus 1. The other factor is going to be a b plus 4. Before I commit to writing the denominator, I'm going to factor the second denominator so that I can write the common parentheses first. The second denominator is just a difference of squares, and for this one I'll essentially get two identical parentheses. One of the parentheses will have a plus sign, the other will have a minus sign. I'm going to divide the exponent by 2, and I'm going to square root the 16. And each parentheses is going to start with a b and end with a 4. And one will have a plus sign, the other will have a minus sign. So now I have both denominators factored, and there's a common factor. Each of the problems at the end of this section, there's going to be a common factor if both denominators can factor. And what I'm about to do is follow my rule to write the common factor first. So they both have a b plus 4. I'm going to write the common factor first. In this first denominator, I'm just going to normally factor it. That first denominator factored into b plus 4 times b plus 1, I just wrote it normally. In the second denominator, I'm going to leave a hole. Instead of writing b plus 4 directly followed by b minus 4, I'm going to leave a hole in the second denominator. So I factored my denominators. I wrote the common factor first, left a hole in the second denominator. Now I'm on to the step to make the denominators the same. To make each fraction have the same denominator, I basically multiply top and bottom by what makes it different. The second fraction has a b minus 4 in the denominator that the first one doesn't. The first fraction has a b minus 4. Now the second fraction has a b minus 4 in the denominator, the first one doesn't. The first fraction has a b plus 1 in the denominator, and the second one doesn't. And in that second fraction, the b plus 1, I snuck in the middle, in where that hole was in the denominator, to make the denominators the same. So now I made each fractions have the same denominators. I'm going to combine and simplify. So I can make the two fractions into one now. This is going to be 2 times b minus 4 plus 6 times b plus 1 over the common denominator of b plus 4, b plus 1, and b minus 4. I just need to simplify the numerator. The first parentheses, as I'm simplifying the numerator, I'm going to multiply 2 times b and get 2b, and 2 times minus 4 and get minus 8. The second parentheses that I have in the numerator, to clear it, I'm going to multiply 6 times b and get plus 6b, and 6 times 1 and get 6. And because this isn't my answer, and because I don't care to write that whole denominator down, instead of writing all 3 pieces of the denominator, I'm going to write LCD, just meaning that's the common denominator. Now in the numerator, I have a 2b and a 6b that are like terms, and I have a minus 8 and a positive 6 that are like terms. So when I go to simplify the numerator, I add the 2b and the 6b and get 8b. The negative 8 and 6 have opposite signs, so I'll subtract and get the sign of the larger and get a negative 2. Not going to write my denominator down yet because I don't really have the best answer. The best answer is going to have a factored numerator, and there's a common factor of 2 in the numerator. So to finish up number 30, I'm going to factor out the common factor of 2 from the numerator, which will leave me a 4b minus 1 in the parentheses. And now I'm going to insert my denominator of b plus 4, b plus 1, and b minus 4. $32 is going to be the same. We're going to skip 1 or 2 problems in the second grouping of problems. They're probably more complicated than we need, and I want to just get the basics down before getting really into the hard problems. So 32 will work a lot like 30. I'm going to factor this first denominator of a squared plus 2a plus 1. It's a trinomial. There's not a number in front of the square term, so I don't need to rewrite and factor by grouping. I know that the signs are plus and plus. The numbers I'm going to put at the end of my parentheses need to multiply to 1, and they need to add to 2. And that's super easy because it's just 1 and 1, because 1 times 1 is 1, and 1 plus 1 is 2. So the first denominator, it's going to factor into a plus 1 times a plus 1. I also need to factor the second denominator of a squared minus 3a minus 4. I know in this case my signs need to be plus and minus. The smaller number is going to get the plus. And I'm adding or technically subtracting. Technically adding, but realistically subtracting. The numbers I'm going to put in are going to be 1 and negative 4. Because if you multiply 1 and negative 4, you get negative 4. If you either add 1 and negative 4 or equivalently subtract 1 minus 4, you'll get negative 3. So the second denominator will factor into an a plus 1 and an a minus 4. So now I'm in a position where I've factored each denominator. I'm going to write the common factor of a plus 1 first to get started here. So this problem I could write as 6 over a plus 1 times a plus 1, writing the common factor of a plus 1 first, writing the factors next to each other in the first denominator. The second denominator, I'm going to write the common factor of a plus 1 first and leave a hole between the factors so I can make the denominators the same. So done with all the way down to my third step. I left that hole. And now I'm going to make the denominators the same. The first fraction I'm going to multiply by a minus 4 over a minus 4. Second fraction I'm going to multiply by a plus 1 over a plus 1. Now the denominators are the same, so I can make the two fractions into 1. I can make this 6 times a minus 4 minus 1 times a plus 1 over... And instead of writing the whole denominator down with the 3 parentheses, I'll just write LCD temporarily for my denominator. Now I'm going to clear the parentheses that I have up in the numerator. I'm going to multiply 6 times a and get a 6a, 6 times minus 4 and get a minus 24, minus 1 times a and get a minus 1a, and minus 1 times 1 and get a minus 1. Still not going to write all 3 pieces of the denominator because I don't have an answer yet. And in the numerator, I'm going to combine like terms. In the numerator, there's a 6a minus 1a that were like terms that will combine to a 5a. And there's a minus 24 and a minus 1 that will combine to a minus 25. Because those have the same signs, I added them. So now, my numerator is going to simplify to 5a minus 25, and my denominator is still going to have all 3 pieces. I'm not going to write all 3 pieces yet because I don't have an answer because the numerator can factor. I'm going to factor out a common factor of 5 from the numerator and be left with an a minus 5, and now I'm going to write the denominator And I'm going to get slick when I write the denominator. Because there's a duplicate factor, I can write that factor once with an exponent of 2. So I wrote the a plus 1 with an exponent of 2 rather than writing the denominator that I had originally written. I'd say this is the best answer for number 32. We do so little factoring with x's and y's, or two variables. Let's just skip on 33. You could skip that for your homework. If you want to give it a try and you can't get it, let me know and I'll work through it with you. But you can skip 33. I'm going to skip 34. I feel like 35 is almost harder than 36, so I'll do 35 with you. And let's see what I can do. I would like to factor each denominator. That first denominator can't be factored. There's no exponent to give me multiple parentheses. There's no common factor. So to get started, I'm just going to factor the 4y squared plus 9y plus 2. And in this one, I'm going to factor by grouping because of the 4 in front of the squared term. So I'm going to multiply the 4 and the 2 to get an 8. I'm looking for plus plus numbers that multiply to that number 8, that add to that number 9. And that's going to be 1 and 8, because 1 times 8 is 8, and 1 plus 8 is 9. I'm going to rewrite the 9y as 1y plus 8y. So in my efforts to factor this denominator, because of the 4 in front of the squared term, I realized my best chance to factor this is to factor by grouping. So I decided how to split up the 9y. And now I'm going to introduce my two parentheses and do my two common factor factorings. The first parentheses is a common factor of a y. And when I factor it out, I'm left with a 4y plus 1. The second parentheses is a common factor of a 2, and when I factor it out, I'm left with a 4y plus 1. And so this is going to leave me 4y plus 1 times y plus 2 on how I factor that second denominator. Both denominators don't factor, but I certainly should write the common factor first. I don't need to leave the whole in the second denominator for this one, because the first denominator is only a single factor. It doesn't have two factors. So in 35, I can rewrite this as an unchanged first fraction, and then the second fraction, I can write the 4y plus 1, followed by the y plus 2. Where this problem's going to get tricky is what I need to do when I make the fractions have the common denominator. To make both fractions have the common denominator, I'm just going to work on the first fraction. The first fraction is missing the y plus 2 that the second fraction has in its denominator. So I'm going to give that first fraction top and bottom of y plus 2. That will make both fractions have the same denominator. Really what I have right now are two fractions with the same denominator. So I can add the two fractions together. And because this denominator is not that much of a nuisance to write, let me just write it down rather than writing LCD. But writing LCD is probably what I would do by myself. Now I need to do the foiling in the numerator. So in the numerator, I'm going to go 2y times y and get 2y squared. I'm going to do 2y times 2 and get 4y. I'm going to do minus 1 times y and get minus 1y. I'm going to do minus 1 times 2 and get minus 2. I'm going to leave the plus 2y. I'm going to leave the minus 3. And now I'm going to get lazy and not write the whole denominator down because I don't really have to. Lastly, I'm going to combine like terms in the numerator. The y squared term, or the 2y squared term, can't combine with any of the other terms because there isn't a y squared term. But the terms positive 4y minus 1y and positive 2y will combine to a single term. I'd go 4 minus 1 is 3 plus 2 is 5. This will give me a plus 5y. And then the constants of minus 2 and minus 3 can combine, and those will combine to a minus 5 because they have the same sign, so I'll add those numbers. Don't think that numerator factors. If it factored, I would factor it by grouping, but it's going to turn out to be prime. And because I can't do any simplifying with the numerator, I'm going to call this my answer after I write the denominator under the best numerator. Oh, maybe 2 more problems and we'll maybe move to the end of this video. So I'm going to do 38, and I'm going to factor the denominators off screen just to save some time, because I believe at this point, given enough time, you should be able to factor the denominators without my explanation. So immediately in my head, I'm factoring 8m squared plus 15m minus 2, and it's going to factor into 8m minus 1 times m plus 2. So that's how the first denominator will factor. And then the second denominator of 5m squared plus 6m minus 8 is going to factor into 5m minus 4 times m plus 2. That would take me about 8 minutes to do in the video, and I just don't want to make the video that long, but I want to do another problem. So you would have to rewrite this as 4 terms factored by grouping. Now I'm at the position where I can rewrite each denominator with the common factor of m plus 2 first. In the first denominator, I don't get a whole. I write the common factor followed by the non-common factor. For the second denominator, I write the common factor, I leave a whole, and I'm done. So I factored my denominators, I'm done with that step. I wrote the common factor first, I left a whole. Now let me fill in the holes and make the denominators the same. The first fraction, I need to multiply it by 5m minus 4 over 5m minus 4. The second fraction, I need to multiply it by 8m minus 1 over 8m minus 1. And of course, I'm making my denominators all line up in the same order. Now I can make the 2 fractions into 1. I'm going to write m plus 3 times 5m minus 4 minus 2 times 8m minus 1. And then instead of writing all 3 factors, I'm just going to write LCD. Now I'm going to simplify my numerators. The first bit of simplifying is going to be a foiling. I'm going to do m times 5m and get 5m squared, m times minus 4 and get minus 4m, 3 times 5m and get plus 15m, 3 times minus 4 and get minus 12. Done with the foiling part of the numerator. Now the distributing part. Minus 2 times 8m is minus 16m. Minus 2 times minus 1 is plus 1. Still going to write over LCD. Now for my numerator, the 5m squared isn't like any other term. It's just going to hang out in the numerator and not change. The minus 4m plus 15m minus 16m is going to be what? Minus 4 plus 15 minus 16. That's going to combine to a minus 5m. And then the constant of minus 12 and plus 1 is going to come out to a minus 11. That numerator doesn't factor, so I'm about to box this and call it my answer, and I'm going to write the factored denominator under the numerator. and call that my answer. I'm going to skip on 40. It's just like what I've just done, and do a couple of the very, very last problems, which are actually really easy, but they're at the very end. So I don't know. Maybe there's a trick. So you can do 39. You should do 39, but it's going to take more time than I care to, and the video is getting long enough already. So last group of problems. One of the terms is a fraction, the other isn't. None of the denominators, or the denominator can't be factored. In problem 42, these instructions probably won't apply anymore. I copied and pasted to make it so I didn't have to write down the steps over and over again. For these problems, these steps don't apply. For this problem, I'm going to make both pieces a fraction by taking the 4 and writing it over 1. When you're adding a fraction to an integer, the common denominator is just the denominator of the only fraction in the problem. So I can rewrite this as a fraction plus a fraction, and the x minus 3, it's the only denominator, so hence it's the common denominator. This right denominator, 1 times x minus 3, is just x minus 3. So really what I have now is 2 over x minus 3 plus 4 times x minus 3 over x minus 3, because this 1 times x minus 3 is just x minus 3. I've made the two fractions have the same denominator. Now I'm going to combine them. I'm going to say this is 2 plus 4 times x minus 3 over x minus 3. These you can't cancel. The numerator has to be completely factored before you can cancel out a common factor. To simplify this problem to get my best answer, I'm going to distribute and clear the parentheses. I'm going to go 4 times x and get 4x, 4 times minus 3 and get minus 12. No need to write LCD, it's just as easy to write x minus 3. In the numerator, I'm going to combine the 2 and the minus 12 and get a minus 10. And then I'm going to factor out a common factor of 2 from the numerator. And get what I'd call a best answer for problem 42. One last problem. Let's just do 43 together, just in case it's a little bit harder. It is just a little bit harder. So for 43, these steps won't apply again. The 3x piece wasn't a fraction. I'm going to make it a fraction by writing it over 1. When only one of the terms is a fraction, its denominator is the common denominator. So I'm going to multiply that second fraction by x plus 3 over x plus 3. This is going to give me 1 over x plus 3 plus 3x times x plus 3 over x plus 3. Now both my fractions have the same denominator. I can add the fractions together. I'm going to save a step here, and I'm going to clear this parentheses by going 3x times x and getting a 3x squared, and 3x times 3 and getting a 9x. So I'm clearing the parentheses rather than writing the parentheses in the numerator. And now I'm going to write the numerator in a nice order with the squared term first, the first power term second, and the constant third. That's a prime numerator. It doesn't cancel. And the denominator, an x plus 3 can only cancel with another x plus 3. So that's as far as I can go with problem 43. And that's the end of section 2.4. You need to be real comfortable with common denominators to move on to section 2.5, because it's kind of getting the common denominators and then doing a step. So get real good with this section before you move on.